gas wears down the rock by abrasion. Through the drill pipes, at the extremity of which the drill bit rotates, a special mud is injected, which the mud engineer prepares and controls. This mud cools the drill bit and consolidates the sides of the borehole. Moreover, it avoids a gushing of oil, gas, or water from the layer being drilled by equilibrating the pressure. Finally, the mud cleans the bottom of the well. As it makes its way along the pipes, it carries the rock fragments, cuttings, to the surface. The geologist examines these cuttings to discover the characteristics of the rocks being drilled and to detect eventual shows of hydrocarbons. The cuttings, fragments of rock crushed by the drill bit, are brought back up to the surface by the mud. To obtain information on the characteristics of the rock being drilled, a core sample is taken. The drill bit is replaced by a hollow tool called a core sampler, which extracts a cylindrical sample of several meters of rock.
Okay.
This core provides data on the nature of the rock, the inclination of the layers, the structure, permeability, fluid content, and the fossils present. After having drilled a few hundred meters, the explorers and drillers undertake measurements called loggings down the hole by lowering to the well to measure the physical parameters of the rock being drilled.
I think it's fine now. I can hear. Maybe you can stop the Okay. All right. Hello, everyone. Sorry for that technical fault. If you can hear me now. And if you can see my screen. Okay. Okay, so I was saying. Oh, if you can all hear me now. Sorry about the technical challenge earlier. And I believe you can see my screen also. Okay, so I will try as much as possible to be as fast as we can about it, or as so we can make up for the lost time. Okay, quickly, I was explaining something earlier that the concept of stimulation in engineering or in oil and gas as a trade is to create a realistic an idea or models of what is actually in existence. You understand? So some of us are used to architectural designs and the rest of them. Now we see that we design first before you start building a house. We are very conversant with that. So the same thing applies in the oil and gas industry. Different sectors of the oil and gas industry that of the oil and gas industry rather that we operate on, we usually create a design or a model first before they start the construction or execution, as it were. And sometimes even some models are also created to run in a dynamic state. What do I mean? So we have the static ones, static designs, which are the designs that are just conceptualized and used for the buildings or for the construction and the rest of it. And then we have the dynamic ones. The dynamic ones are the applications of software that help us to also monitor progress and a lot of other operations that are ongoing. So when, for instance, a facility is to be constructed, we use some different simulation tools to simulate how it's going to look like. Imagine you are going to drill, like the video you are watching just now, is a video of a drill of a drilling operation in a rig. And those that's also like a model or a simulation concept, right? And how it works and all that. But there are other ones that also show as live readings, give us live readings or monitoring and the rest of it. So some of these softwares or simulation tools that we have in the industry, we have some which are used for reservoir simulation, like what you can see in the screen that we'll be talking about or introducing ourselves to. We have the reservoir simulation, we have the HYSYS simulation tool. HYSYS is spelled HYSYS. HYSYS simulation that is used for chemical process simulation. You understand, to create such models. Then we also have the um, the take some. We even have a lot of them. We have some that are used for drilling simulation. We also have the ones that are 3D designs. 3D means three-dimensional design. That's designs that are used to just model how the structures will look like or how the features look like. Examples of such are your 3D AutoCAD. Many of us must have heard of AutoCAD before. Uh, 3D AutoCAD. You also have the PDMS. PDMS is Plant Design Management System. Plant Design Management System. And a lot of other ones you have. You even have the AutoCAD and Auto Plant 3D. Now the PDMS, for the purpose of this course, we'll be touching three basic ones, or some major ones, which are the reservoir simulation, the HYSYS simulation, and the PDMS. HYSYS is for chemical process simulation, and then the PDMS, which is plant design management system. All right. So basically, we're starting with the reservoir simulation. Now, the reservoir simulation is a concept of creating simulation design for reservoirs. What are reservoirs? First of all, reservoirs are those storages or those deposits or those um, locations or points where we have large, large quantity of hydrocarbons. I choose to use the word hydrocarbon because it's not only oil that might just be there. You could also have gas there. Okay, so the, the, what we are going to be discussing today majorly is the reservoir simulation. Remember, I've mentioned some other ones before now. All right. So the reservoir, as I said, large deposits of what? Of hydrocarbons, mostly found in the earth crust. Okay. And we could simulate the operations, the dynamics, the way they look like, what happens there, what are the features, what's going on in there. That's the purpose of reservoir simulation. Now, what are the benefits? What are the things reservoir simulation helps us to achieve in simulating? Now, I'll just show us some, if you can see my screen, some of the questions that reservoir simulation helps us to answer. Number one is, if you can hear me, number one is that it tells us how how should the field be developed to maximize the economic recovery? Most times, before you go into such processes, a lot is pumped into such processes. A lot of funds are put into such processes, and um, we need to also optimize that that reservoir to ensure that whatever we are getting out is able to cover for every penny that is spent and even more. Unfortunately, as of today, I think many of us are aware that the price of crude oil in the market has really crashed. In fact, it has even gone in some places that have gone below zero. That's it's reading at a negative value now. That price of crude oil in the market, especially US crude. It's not like US crude, nobody buying it. It's cheaper than your nose mask right now. It's that bad. But it was not so before. This is just because of the challenges, some of the aftermath of the epidemic. We know that for years now, oil and gas have been one of the major source of energy all over the world. Hence the demand for the large demand for crude oil and a lot of money that's put into such projects. However, one of the questions that reservoir simulation helps us to achieve is that it helps us to know how a field should be developed to maximize the economic recovery. For us to be able to make more money to ensure that we don't run at a loss. Sometimes some people, okay, first I need to even say this. I think many of us must have done some other areas of introduction to oil and gas to understand the process of how we get this oil and gas right from the point of exploration, where we do some checks or survey, you understand, to determine where these reservoirs are. Then we now go into drilling. From drilling, we go into refinery, some level of transporting also going on between the through the pipelines or transmission line to the refinery. At the refinery, the crude oil is the product is being processed, purified, and then also broken into several fractions that can be used for different stuff. Now, these fractions are now transported down to storage points, and from the storage points, they are metered to the filling stations or the dispensing stations for different areas of their utilization. Okay, now all this, a lot of funds are put into this whole process. Each of these steps that we mentioned, from exploration to the point of dispensing, there are different simulation tools that can be used to tell or describe the features at this point. And for the reservoir simulation itself, it will help us to maximize the economic recovery. Now, one other thing that it does is what is best, what is the best enhanced recovery scheme for the reservoir? What will give us the best recovery structure? What will be the best design to be given for such reservoir so that have we can optimize the profit from such reservoir. And again, another question it helps to answer is why is the reservoir not behaving according to predictions made by previous engineering studies? If, for instance, they are predicted that okay, this reservoir will be producing up to maybe 500 million standard cubic feet per day of um, of crude oil. But it's not crude. That was what was gotten at design concept or at the point of exploration. But by the time you're running, you discover that it's not hitting up to that value that was estimated. Through reservoir simulation, we'll be able to discover all this. All right. Now, another part that it also helps us to answer is what type of laboratory data that may be required. Every factor, everything taken from every content or at every point where we start getting information, whether from the seismic data during exploration or even the content we get through drilling, we usually take them to the lab and run some tests on them. So the kind of laboratory data that will be required through through reservoir simulation, we're able to get that too. A lot of other benefits that we can also get from reservoir simulation. Now, another thing is, what is the best completion scheme for the wells? We have the reservoir, then we have the wells. The wells are what are the connections between the reservoir and the surface. So for us to get the crude oil to the surface, we have to drill the well. The video you were just watching just now um, is a video of a rig and a drilling operation going on there to get to where the oil reservoirs are. Okay, where the oil reserve is. Now that well, we need to also ensure that there is a completion scheme. So we don't just dig a well or drill a well. You understand? We use the term drilling of well. We don't dig a well. We drill the well and then have a have we should not just drill after drilling the well, we discover that maybe the well is not producing, it cannot sustain or stay the lifespan that is estimated. I was involved in a project some years back, and the company, the client, they had speculated ours was just to do the construction and the installation and all that, what called EPCM, that's in procurement, construction and management. And they discovered later on, after they invested so much resources into the well, it's a very popular company that was on client, if I mention their name. And they discovered much later that the well, the sustainable, the lifespan, what we call lifespan, how long the well can continue to produce uh, produce oil or hydrocarbon products. Okay, the lifespan of the well was below 25 years, was below the duration that they had even speculated earlier. But all that they didn't know on time because they had not, from their own end, they had not done a proper job. And unfortunately, they had to shut that project after a lot had been spent. And then they started querying themselves in their company, okay, who was responsible for this, who was responsible for that, who is responsible for all, and the rest of it, because a lot has already been lost. Now, another is that it's, is it necessary to do physical model studies of the reservoir? Is it necessary from the reservoir simulation we'll be able to find that. Now I need to quickly say this. There are different um, softwares that are used for reservoir simulation. For popular ones are Python, like PyTHY, and Eclipse. Okay, have Python and Eclipse. So some of these ones I've mentioned earlier and more are some of the reservoir simulation, um, some of the advantages or benefits that we get from reservoir simulation. Okay, I'll be giving you an assignment. One of the assignments I'm giving you already is in your own words. You're going to explain the okay, in your own. One of it is for you to give a comprehensive summary of reservoir simulation. Give a comprehensive summary of reservoir simulation, stating its importance in today's oil and gas industry. Okay. Now, quickly, I'll go back again to our slides for today. I hope you can see my screen. Hello, can you hear me? Can you hear me? Can I go on? Can I go on? All right. Okay. If you can all hear me clearly.
I will increase the bandwidth.
I didn't get that.
No, I join it here now.
Okay, if you can all them, I will just go on whatever. Look, can you all hear me? Somebody's talking. All right. Hello. All right, please let's go on so we don't get too distracted. Now, the reservoir management plan. This much, even if we don't get everything completely, I'll still get this across to us somehow. Okay. Yeah. I'm still on. I'm still on. I was hearing your phone, not my phone. Hello. So, quickly, the model for reservoir management plan. Our outline generally for this program is this. First, this material that I'll be sharing, we looked at the reservoir engineering techniques for forecast, for results for estimation, and the rest of them. Talk about the analog, the decline curves analysis, material balance, and reservoir simulation. Now, and after that, it also looked at, or we also looked at the probability and determinism, reservoir model component, statistic model. I mentioned something about some statistic model and dynamic model, then the grid, rock property modeling, dynamic models, major laws used in reservoir simulation, numerical techniques in reservoir simulation, scaling and upscaling, the pseudo and effective properties, black oil model slash compositional model, and a host of other topics that would be looking at. Also look at the reservoir simulation task, history match, and the rest of it. Also have bear in mind that you are going to be given some assignments in this regard. I'll be sharing that hopefully before the class ends. And on that document, let me just see here. Yeah. Okay. On the document, I would put it on just take note of these assignments quickly because while I'm talking, I will also be giving us these assignments. I hope you can see the screen. If you can see my screen, these are the assignments. So take a screenshot of it, and I'll also on it also have some links for further study. I have to do that quickly so you don't miss it. The assignments, number one, explain the 5 basic steps to building a model. Explain the 5 basic steps to building a model. Number two, in your own words, explain the concept of geological modeling. Then give a comprehensive summary of reservoir simulation, stating its importance in today's oil and gas industry. Now, we must go through there of C is what is upscaling? Why do we upscale? We must go 3 is explain the meaning of reservoir factor, or I'm sorry, recovery factor. This is recovery factor. Okay, and we must go 4. What factors are, or number 4 rather, that is what factors are considered in chemical process simulation. Your mail is to be your assignment is to be submitted to engineer.ima.jpts@gmail.com, and you ensure that the subject of that mail can be sorted out is written as GST 401 assignment 1 your center, the name of your center. If you're in Ikorodudu Center or you're in Kafanchan or you're in Abuja or whatever center, if it's Abuja 1, Abuja 2, or um, Kaduna, Kano, whatever name your center is, please you put it in bracket and submit. Alright. Now there are also some links here. Uh, um, some links for further studies also on this. Um, so while I continue with the slides, just in case don't meet up at the time, please take note of them. Okay, you can take a screenshot with your phone. So quickly, please. Um, Back to our discussion. After our discussion, so we have the modeling techniques that are used in the modeling techniques uh, through the field life. Through the field life, different modeling techniques. We have analog, we have decline curve analysis, then we have material balance and reservoir simulation. These other ones, these analog to decline curve is one we make use of graphs and all the rest. Many of us have been following with the NCDC reports on this pandemic and COVID-19. You discover that you hear them always saying we want to flatten the curve, want to flatten the curve. So these are just graphical representations or readings that we usually deal with in reservoir mode simulation. Then we have material balance. Material balance is to talk about the various components and equations that are eventually used in this simulation. Material balance is taking maybe like the mole ratios, some factors of pressure, temperature, and the rest of them, bringing them into cognizance and trying to use that, especially how, how much of each component present and to what proportion are they relative to others. So that's what material balance talks about. There are several factors that are into, um, looked at when talking about material balance. Okay, so we have the reservoir simulation. We have the reservoir simulation, which is the cocoa of this, the main bone of contention. Okay, this is what a decline curve looks like. It's a basic tool for forecasting production from a well. Okay, then we have sufficient production. Today we are just going to focus on reservoir simulation as the focus for this particular class. And then in our subsequent class, by God's grace, we also look at other aspects, the 3D modeling and also the ICs. We're also going to do a number of research and studies too on your own to implement what you're learning from this class. Okay, so this is what the decline curve looks like. This is what the decline curve looks like. Let me try to expand it so you can see. Better. So usually the decline curve looks at production rate against time. We start just a minute. Okay. The sharing, how do I share that assignment? How do I? Where is that? I'm not seeing it. So, well, as I was saying, the material balance looks this way. You have a lot of equations or some complex equations that are usually used for this. Okay, it's an alternative, largely independent method of estimating the original hydrocarbons in place. So we're able to estimate the original hydrocarbons that are in place using material balance. also use sufficient production data. Those are some of the advantages it gives. Use of sufficient production data. So, but for reservoir simulation, the tool is used by combining different properties: physics, mathematics, reservoir engineering, computer, and um, quite a number of other factors in reservoir simulation. This is what it looks like. If you can see them. Okay. So once again, I would want to quickly post the assignment. So this is what we have. The reservoir simulation helps us. Reservoir simulation leading to prediction of reservoir behavior. Those are some of the advantages. No, reservoir simulation studies are very subjective and they vary from one simulator to another. Okay, then the garbage in, garbage out. If you put in wrong information, certainly in a reservoir simulation, you also get wrong. If you put in wrong data, you are going to get wrong information. Okay. All right. So quickly, I just want to protect this again. The assignment, so you can see the little challenging tool. That's fine. Okay. I believe you can see this now. All right. If you brought that now, so if you can see this, just take a snapshot of the assignment that you have. Take a snapshot of the assignment and also some study links for reservoir simulation, some things you can watch. I've not seen the handout. Wait, no, I've never seen the handout. The handout. Okay. Please ensure that your assignments are completed. Make sure you try to do some studies also and answer these questions, send them to the mail, and then you also use that subject as stated in that mail. Now, there are 5 basic steps for building a model. Number 1 is structure. Number 2 is the correlate formation. Number 3 is grid, that's the arrangement. Then number 4, we look at the model phases. Then petrophysical properties. The petrophysical properties in reservoir simulation talks about which of the porosity and permeability of the um, of the cells. You understand, of the cells in the reservoir. The reservoir, the units here we get it from, they are described as what cells. So porosity and the permeability. Porosity talks about how porous the cells are, and how permeable, how well they're able to absorb fluid. It's what we talk about there. So those that describe the petrophysical properties, which are which is part of the 5 basic steps in building a model. Thank you very much. I want to believe that be able to get this short and be able to get the assignment. Please ensure you take your assignment very seriously and ensure that